Let's look at the constant speed problems, and we'll be using the most basic of kinematic equations, S equals Vt, that we derived from the graph of motion of the out for a drive activity with a car moving through various distances, and then we made a graph, and then from the equation developed from the graph, we end up with S equals Vt, where S corresponds to the y variable, t corresponds to the x variable, and then v is the slope of the line that's traced out by the car as it moves. So S is the displacement, and this will be measured in distances of meters and miles or feet. V would be the speed measured in meters per second, meters per hour, miles per hour, kilometers per hour, and then t is time, being seconds, minutes, or hours. So as we read through these stories, and all of these stories are little mysteries in which you'll be given two of the three variables here, and then you have to use the rule of physics here, the first kinematics equation, to figure out the missing information. So it's helpful to make a list of all the possible information that you could be given. So in this case, it's V, S, and T. And then as you read the story, you go through it and you underline and you underline. So we're going to have 1610 meters, and then you're running around it in a time of 240 seconds. Now, how do I know it's a time? Well, this 240 has seconds, and I know that this is a displacement or a distance because you're running around a track, because it has meters. So this will be 1610 meters, and this will be 240 seconds. And then the question is how fast? The question always tells you what you don't know. So rearranging that equation, well, we can start out with S equals Vt. So we could do S equals Vt. That's how we've developed it. S is going to be 1610. V is what we're looking for, 240 seconds there. And so we're going to divide 240 over, divide 240 over. Cancels on the right, appears on the left. And so you put into your calculator 1610 divided by 240. And we're going to get 6.708. So 6.708. Which, if you look at our information here, we're only going to have two significant figures here. So the 0 is going to tell the 7 how to round. So 6.7, and that will be meters per second. Meters per second. And that answers the question. It's how fast you were running to complete the mile. Notice how just in the question, or in the scenario, I switched from meters to mile. That's because there are 1,610 meters in 1 mile. So this would be you're running around a track 4 times to complete the mile, and it takes you 240 seconds or 4 minutes to complete the mile. That's a pretty fast mile. All right, next scenario. Bruce drives his Lamborghini at a speed. I know it's a speed because of the units here, for a time of 3.5 seconds. Notice how this time you're given the word time tells you that, as well as seconds. So both of these guys tell you that that number refers to seconds. So in our list of givens here, we can go 45 meters per second and then 3.5 seconds. To block the truck from hitting the police van. So we have some implied things going on here. Some truck is going to run into a police van, and this guy Bruce, who's in a Lamborghini, sees that and speeds up to get in the way. I don't know why he would do this, but he did. So S equals Vt. How far was he driving for that? So we're going to have 45 and then 3.5, and this time we're going to be multiplying. So S equals 45 times 3.5. And that gets us 157.5, but remember, we're going to have to round this, We have 2 sig figs and 2 sig figs, so we're only allowed to have 2 sig figs here in our answer, so that'll be 160. So 160. And because we have meters per second times seconds, so let's look at our units up here. Meters per second times seconds. So we're dividing by seconds and then multiplying by seconds. And as we saw in previous unit of unit conversions, when you divide and multiply by a unit, it cancels, and the only thing that's left is meters. So we have meters here. And this unit needs to be consistent with the question and the thing that we're looking for, distance. So meters measures a distance, which is what we were asked for. All right, Clark flies directly from Tiny Town to Tubeberg, a distance of, okay, here we're given a distance, and then we're given a speed of miles per hour. Okay, that's good to know about the units here. So distance of 1250 miles, and then a speed of 3,300 miles per hour. Now the question is how many minutes? So we're asked for a time, but if you notice our units are in hours, we're going to have to convert whatever comes out of our kinematics equation. So we have S equals VT. This is going to be 1250 equals 3,300 T. Now we're going to divide both sides by the 3,300. Divide both sides by the 3,300. This will cancel. T is left alone. And using our calculator, 1250 divided by 3,300. I have 0.378, and then the 7 and 8 are repeating, so 0.378. And we have, well, this tells us 2 sig figs. So we don't need to go any farther than that because that guy is going to round. And you need to keep in mind this is hours. So we're going to need to convert hours to minutes. So 0.378 hours. And we're going to need to go to minutes, which makes hours on the bottom. So we have hours on the top of the fraction, hours on the bottom of the fraction. So 1 and 60. So multiply that guy by 60. I'm going to get 22.68. So that's 22.68. And now that we're all done, I was starting to round too soon there. Now that we're all done, we're going to round that, and we're going to get 23 minutes. Now, if you're paying attention to the story, somehow he's flying a huge distance, over 1,000 miles, to drop Chinese food at his folks' place. This is not a normal guy. Or maybe he's just really nice and the folks are, they just really love the food from that particular restaurant. All right, Peter rides his bike through town to deliver pizzas. We have a food theme here. Time of 15 minutes, speed of 25 miles per hour. Notice that we have minutes and hours mixed here. This is not allowed. We're going to have to do a unit conversion. 15 minutes and a speed of 25 miles per hour. How far away from the shop is his delivery? All right, so how far is this? Let's convert 15 minutes to hours before we go any farther. Last time we had to do the unit conversion at the end of the problem after we did our kinematics. Now we're going to have to do unit conversion first, and we're going to have to get rid of minutes. Those on the bottom, replaced by hours. And that's going to get us 0.25 hours. All right, now in our kinematics, S equals VT. V is 25, T is 0.25. So it takes him 1/4 of an hour to deliver the pizza. And if he's able to maintain a consistent 25 miles an hour, that's pretty impressive. Because if you're on a bike, 25 miles an hour is pretty fast. So that's 6.25 miles. That's all the way across town. All right, a lady named Helen is going to parachute out of a plane from an altitude of 50 meters. Okay, even if you don't know what the word altitude is, the units of meters here is a clue that that's a distance. So 50 meters. And because she's parachuting, that means that she gets to fall with a constant speed of 7.5 meters per second. Which, if you're falling, you don't want to be going too much faster than that because that'll wreck your knees when you land, if that's the case. So parachutes are a good thing. So she's going to be falling 50 meters. And if you remember back in number 1, 1,600 meters was roughly a mile. So this is almost 2 miles that she's falling. Without a parachute, she'd end up going really, really fast and probably die, but the parachute's going to save her. All right, so we've got a t times 7.5 over here. We're going to divide both sides by 7.5, get the t all by itself. So we're going to have t equals 3050 divided by 7.5, and we have 406 point, and then the 6 is going to be repeating. But again, looking back here, we only have 2 sig figs, so we're going to have to round this guy. That'll be 410 seconds, which is a little over 6. It's a little bit less than 7 minutes. So that's a long time, and you don't want to be falling for that long without a parachute. All right, Barry is going to speed walk 800 meters in 42.5 seconds. I don't know why he doesn't just run. In fact, that actually is running. 800 meters is about half a mile. Normal people don't do that in too much less than 2 minutes. So 800 meters, that's a distance. 800 meters in a time of 42.5 seconds. So 42.5 seconds. And somehow he's going past your window, and that's definitely going to be flashing past your window there. So S equals VT, 800 meters, V 42.5, and this time we're going to be dividing by the time. It's not much of a workout if that's all he's doing, because normally you want to spend a little more time than 3/4 of a minute. 42.5. All right, that's 18.8. 18.8, 2, 3, and then so forth. But again, this time we only have one significant digit. If you look back here at the beginning, we don't have any decimal points here. It's just 8 and a bunch of zeros. So 1 sig fig, this 8 is going to tell the 1 how to round. And we're going to round that guy to 20 meters per second. And no extra digits and no decimal point.